Hey there, Year 11. So I've got questions on Padlet for question 10A, 7B, and C. So let's do 7 here first. The 7B and C. Let's see, what are we doing? 7B. We are looking at, for each of the following, use one number line on which to represent the sets. Okay, so it looks like you want to illustrate this visually on a number line. So I'm just going to quickly draw a number line. So let's do, this is a number line. Let's do B. All right, B. Here we go. So B wants you to illustrate -2 to 5 inclusive, and then what's the other one? And then you have all real numbers excluding -2 to 5 on the one axis. Okay, so here we go. In the first set, I'm just going to do a point of reference, so say that's 0. So from -2 to 5, say you don't have to be accurate in the scale here. It's more to illustrate which areas of the number line you're working with. So -2 is clearly, say, somewhere over here, and then you've got 5, say 5's over here. Then because they say inclusive, I'm going to use a closed circle to say that I'm going to include -2, and then same thing with number 5. I'm including number 5, and then remember, we are now connecting a nice solid line between the two dots to indicate that those values are, everything in between is also included. So I've got from -2 to 5. That's my first set. So that is your, I'll just write it above it to help you. So -2 to 5 inclusive. Okay. Then our second set, so notice that there's a comma here to indicate that you've got a second set now, and we want all real numbers, and then the backslash means excluding anything that is -2 to 5, including both -2 and 5 we don't want. Okay, so that means in my second set, I know that I can have any number except -2 and 5 and anything in between it. So anything in between -2 and 5. So I'm going to use a solid line to indicate that anything in between -2 and 5 and -2 and 5 inclusive, I cannot have. So all of that I cannot have. Now, by drawing a solid line like that, that means I will have. So how do you include the ones you want? Well, we said we wanted all real numbers, so you don't include that line there. You're saying that everything in between I don't want, and so how do you show you don't want it? Don't draw it. Okay, whereas a solid line on where you do want, this is what you should be drawing. So you should then say, I want everything else. So everything else is outside of those regions. And so I use an arrow to indicate that it's everything onwards to the positive side after 5, and then everything negative less than -2. So that indicates that I have every number that I want. The only part I didn't want was anything that was 2, so -2, sorry, and then anything in between -2 to 5, and I don't want 5. So that's why there's a closed bracket there. If I did want -2, then it would have been an open bracket and say anything from -2 to 5, and that would imply that I am able to include -2. Then you would use a nice closed circle there, okay? So that there would indicate in green the second set. Okay, so that's what you would do for 7B. There are 2 sets, and they want you to illustrate that on a number line. So if I did it the same again for, say, C, let's do C. So C here, there seems to be, wow, there's three number lines there. Okay, so let's do this again. No, I'll use this one instead. So maybe I'll just do it on the bottom here. All right, so C, what is C asking us to do? So C wants us to have a look at from 3 to infinity. So again, I always use a 0 as a reference somewhere. So put a 0 in. So we want 3 to infinity. So say, I'm going to do 3 here, just because 7 is going to be a bit above there. So 3, I want 3 inclusive. So there's a closed brackets on 3. And then it's all the way to infinity. So that means on my ruler, I'm going to say I want everything from 3 onwards. So I'm going to use my arrow to say that's from 3 all the way to infinity. So that's my first group. So 3 to infinity. That's what that number line represents. Then the next one was from negative infinity up until 7. So I'm going to use another color here. So where 7, say 7 is double 3. So 7, say 7 is here. So I want all the way up in 7. That's the largest number that you can have because it says inclusive of 7. And then every number that's before that. So I'm going to draw a nice solid line to say every number less than 7 all the way to negative infinity. So I'm going to use an arrow there. And this now represents negative infinity up until 7 inclusive. Okay. And then finally, what do they want us in the third one? And this last one is very special. He says that it wants everything that is 3 and above. So we've already drawn that in red. And they want everything that is from negative infinity up to 7, which we've drawn in purple. But the intersection sign means where do they both have in common? Now, if you have a look at the two lines that I've drawn, where do they both have a region that's in common? And we can see that it clearly is from 3 to 7. Both of them include a 3 all the way up until 7. Okay, so in the red line, there's more numbers from 7 onwards, and in the purple line, there are more numbers in the negative.
7 kilometers.
Oh, that's my
Completed 1 hour.
That was my walking that I forgot to finish. Anyway, so from 3 all the way to negative infinity, that is in the purple line exclusively. So the only part they both share in common must then be only within the regions of 3 to 7. So in my third line, I'm going to use the green line now to illustrate it. Clearly, I can have 3 in both lines, and both I can have 7. And I want it only from 3 to 7. That's the only parts that are in common. So this is where 3 to infinity is in common or intersecting with negative infinity to 7. Okay, inclusive. That's essentially what that means. And that's 7B, 7C there. Okay. I'm just thinking what's in 10. So there's 10A here as well. Let's see if I can do 10A. I'm gonna do it on this side probably. Yeah, all right. 10A, let's have a look at 10A. So 10A says the same thing. Describe each of the following intersections of intervals as simply as possible. So they want you to describe in 10A as simply as possible, meaning that we're going to use some sort of set notation. So this is where if you can visualize it on a number line, negative infinity to negative 3. Okay, so I'm picturing in my mind, and it's intersecting with negative 6 to infinity. If you're finding this tricky to do, that's essentially what we were doing over here. You may need to visualize what negative infinity to negative 3 looks like, and what negative infinity up into negative 6 looks like. So in my mind, this is what I'm seeing. Okay, I'm going to draw a very rough sketch of what I'm seeing. I'm seeing that if 0 is my reference here, negative 3 is here, negative infinity all the way up to negative 3, not inclusive, and then negative 6 to infinity, not inclusive, looks like that. Oh, sorry, to positive infinity. Whoops. So it looks like this, to positive infinity. So to me, in my mind, I can already see that the parts that they intersect has to be from negative 6 to negative 3, but not inclusive on either end. So if I were to write it, the best way to describe that entire thing was just simply say it's from negative 6 to negative 3, non-inclusive. That's essentially the region they're looking at. So that's what they mean by as simply as possible. It's from negative 6 to negative 3, non-inclusive. And the power here is to be able to visualize it on a number line without drawing it, of course. So if I were to do B as an example, in my mind I'm thinking, okay, 1 and all the way to the left of 1 on the number line, and then I want that to be intersecting 4 to infinity. And in my mind I'm like, well, no, there's nothing. There's absolutely nothing that's in line with that. They're both two separate lines. They have nothing intersecting. So in fact, this would be null. Sorry, that means 0. There would be nothing. So the symbol that you would have learnt over here, where is it back up here again? Null means an empty set, means there is nothing in common. So you can see there 2, 3, 4, 5, 6, and 7 have nothing in common. We use what we call an empty set. Okay. So going back here, an empty set, whoops, where are we? B would be an empty set. And again, you can try it by drawing if it helps you to visualize. 1 is over here, 0 is here, so negative infinity goes up to here, not inclusive. And then 4, which is over here, not inclusive all the way to positive infinity. Clearly they don't intersect. Okay, so that's one way of doing it, drawing it if it helps you. But eventually you want to be able to answer the questions without having to draw the number line, because it means you have a really strong understanding of the language and you can visualize what you're working with. If you're prone to mistakes, then yeah, draw it. Draw, illustrate it. It's fine. If you know a small bit of time to illustrate it, but helps your accuracy, then by all means, you must do it. So C, when I look at C, I'm seeing negative infinity, so everything to the left of 0, inclusive, and negative 6 to infinity. They both clearly intersect from negative 6 inclusive to 0 inclusive. So that's how I'm seeing it, and that's in my mind. But you as you practice, you'll get better at it, and then you can do union and intersections all in your mind as well. Okay, so I hope that video helps clarify what the questions are asking you to do. But that's really the power of the set notations and language to illustrate what you want to say or which regions on a number line using interval and set notations. Okay.